So this 1.3, the second part today, we will do further with the rational expression. I think yesterday I called it part C, rational expression. And yesterday we have done multiply, divide, add, subtract. Now we have extra topic here in complex fractions. Okay, so we have done this yesterday, and we will start with complex fractions. And then later on, we will also simplifying or rationalize denominator. And then we will have some extra difficult combo topics. Combo topics. Let's see. For the complex fractions, suppose, for example, I give you the foundation first from algebra. Suppose, for example, we have 3/4 big over 5/6. Suppose we have a fraction over a fraction, that's what we call a fraction, complex fraction. And we want to simplify this. Now, there are two methods to do this. Method one, we rewrite that as division. 3/4 over 5/6. And then we write that as a multiplication by the reciprocal. And of course, cross cancel whenever possible. I'm dying. Nine over 10. That's our final answer. This method one here basically follows order operations. Let's see another example. Suppose I have 2/3 minus 5/8 over 5/6 plus 3/4. Using method number one, I follow order operations. Using method number one, so let me separate it. Using method one, following order operations, then I will simplify the numerator and the denominator. On the numerator, I have LCD 24. Oh, this is 16, right? 3 times 8 gives me 24. So 2 times 8 gives me 16. And then 8 times what gives me 24? Times 3. So the numerator also multiplied by 3. That would be 15. The denominator now have LCD 12. With the same procedure, we get this is 10 and this is 9. Going forward, this is 1 over 24 over 19 over 12. And multiply by the reciprocal. Let me skip one little step there. Multiply by 12 over 19. Cross cancel. I get 1 over 38. This is method 1, basically a conventional method following order of operation. Now, let me show you the second method, which I suggest you to use because it's faster. And since you are already in Precalculus, you should be able to do it faster. Okay, I call this LCD method. This is what I call that, LCD method. Other textbook, maybe our textbook, call that clearing the denominator. Clearing the denominator. Okay, now, so what it does is as the following. Let me rewrite the question. 3 over 4, big over 5 over 6. Now, we will see this as two different numbers. Okay, and then multiply the top and the bottom by the LCD of those two numbers, of these two fractions. The LCD of 4 and 6 is 12. So I multiply the top by 12, multiply the bottom also by 12. Remember, when we simplify fractions, let's say if I have 20 over 30, when we simplify fractions, we divide by the common factor, right? We divide by the common factor. Okay, and since we divide by the same numbers, we will get a simplified fraction, but the same value. They are still the same value because we divide the numerator and the denominator by the same number. Okay, now, so in other words, as long as I multiply or divide by the same non-zero numbers, the value of this fraction will be the same to this. See, I basically multiply by 1. Right? I basically multiply by 1. So the goal is multiplying by the LCD. Why LCD, Thomas? Because LCD for sure is the multiple of the denominator, therefore it's cancelable. Right? 12 divided by 4 is 3, then multiplied by 3 gives us 9. Over 12 divided by 6 is 2, multiplied by 5 is 10. A lot faster. Okay, let's do it again. 3 over 4 over 5 over 6 multiplied by 12 over 12, which is the LCD of 3, 4, and 5, 6. Now 12 divided by 4 is 3, multiplied by 3 give me 9. 12 divided by 6 is 2, multiplied by 5 is 10. Bang, you're done. Now, we will apply this to the second example, the same notion. So in our example 2, we have 2 over 3 minus 5 over 8, big over 5 over 6 plus 3, 4. Now, what is the LCD for all the fractions? 3, 8, 6, and 24. That's 3, 8, 6, and 4. The LCD is 24. Then multiply this. 24 divided by 3 is 24 divided by 3 is 8 times 2 is 16. Okay. 24 divided by 8 is 3 times 5 is 15 minus 15. 24 divided by 6 is 4 times 5 is 20. Plus 24 divided by 4 is 8. I'm sorry, is 6 times 3 is 18. And this becomes 1 over 38. So you see that it's faster because we do more computation mentally, okay? Yeah, we do more computations though, not less. We do more computations, but those, even though we do more computations, most of them are actually simple computation that can be done mentally. So we spend more time, I should not say more time. We actually do more computation, but because those are simple computations, we can do them a lot faster. Notice that I don't deal with fractions actually. Right? It seems like I have fractions, but the way I did it, all of them arithmetic without fractions. It's different from the first method when I did that. Okay? Now, then, how do we bring this to our precalculus level? Now, by the way, we have this type of question in beginning algebra and intermediate algebra. So we have seen this before. Now, number 50, for example, I hope you have your textbook already. Okay, number 50, we have x over y squared minus y over x squared, big over 1 over y squared minus 1 over x squared. Now then, how to simplify this? What's the LCD? Or overall LCD? Y squared, x squared, x squared, y squared. So the LCD is x squared, y squared. Now then, what happened to the top left? On the top left, x squared, y squared, cancel y squared, give me x squared. Then multiply by x. That gives me x cubed. Minus x squared, y squared, divided by x squared, give me y squared. Multiply by y, give me y cubed. On the denominator, we repeat the same story. X squared, y squared, divided by y squared is x squared. Multiply by 1, give me x squared. Likewise, x squared, y squared, divided by x squared is y squared, times 1 is still y squared. Now, all of a sudden, it becomes a simpler fraction. It's not simple yet, but it's simpler. Then from here, we go on factoring in case something can cancel. The bottom one is we see x squared plus x plus y, x minus y. That's difference of squares, right? The top one, difference of cubes, x minus y times x squared plus xy plus y squared. Then something cancel here. Then our final answer will be x squared plus xy plus y squared over x plus y. Number 54. Oh, by the way, number 52 first. I will not do this problem, but I'll just show you what happened if they use negative exponent. Y to the negative 2 minus x to the negative 2 over y to the negative 2 plus x to the negative 2. Now, these are not multiplication, so you cannot just make it positive by bringing it to the other side. No. You have addition here and subtraction. So I'm supposed to rewrite it this way. 1 over y squared minus 1 over x squared for the numerators. And then 1 over y squared plus 1 over x squared for the denominator. Okay, and then from there you go on the way we did number 50. Now, can you try number 54 maybe? 54, I would like you to try, this is 2 over w minus 4 over 2w plus 1, all of them divided by 5 over w plus 8 over 2w plus 1. Okay, let me give you how many minutes? Maybe 2 minutes to do this problem. Try it. So on the top left, that will be canceling the w. I get 2 times 2w plus 1. I will distribute that later. For now, let me just write it down. Minus the top right here, 2w plus 1 cancels. Multiply w by 4, give me 4w. The bottom left, the w cancels. So I have 5 times 2w plus 1 plus 8w. Then on the top, then I get 4w plus 2 minus 4w over 10w plus 5 plus 8w. Which, if I combine my terms, I will get 2 over 18w. Now let me ask you to try the last one before I go on to the later topic, number 60. Number 60, I have 1 over x plus h minus 1 over x over h, which you can see as h over 1. So the LCD is actually x times x plus h. Okay, finish it up. Let me give you 1 minute maybe. So what happened on the top is we will get x minus x plus h over h times x plus h. Distribute x minus h over h x plus h. That's negative h on the top. We'll cancel with the h at the bottom later. So the final answer is 1 over negative 1. I'm sorry, negative 1 over x plus h. Okay, now how about rationalizing the denominator? That's if we have radicals on the denominator, then we usually need to rationalize that. And to rationalize that, we multiply by the conjugate. For example, number 62. 16x squared minus squared over 2 square root of x minus square root of 1. Then I will multiply by 1 in forms of the conjugate of the denominator. Conjugate if they have exactly the same terms, except that the middle sign is opposite. So plus 2 radical x and radical 1. The sign here has to be opposite. Okay, so that we can invoke difference of squares property. Okay, let me delete the colors. So it's quite destructive. That will give us 16x squared minus y squared times 2 radical x plus radical y. While at the bottom, this guy times this guy will be 4x minus radical y times radical y will be just 1. Now, we're supposed to be done here until we realize, oh, you know what? We can actually factor this, right? We can actually factor that. And one of the factor of this guy is will cancel this guy. So let me factor it now. That's equals to, on the top, 4x plus y, 4x minus y, 2 radical x plus radical y, big over 4x minus y, cancel 4x minus y. So we get as our final answer, we get 4x plus y, 2 radical x plus radical y. Okay, now we usually have this type of question, like of rationalizing the denominator. The type that we usually encounter are the one have a square root at the bottom. Now, number 64 is quite rare, but it is at our level. It is at our level. We have 1 over cube root of x plus cube root of y. And we want to rationalize that. The thing is, this is cube root. And how should we rationalize that? The idea will be we multiply by something so that we can use the cube root disappear. Basically, we need to cube that. Basically, later on, I want to have something looks like cube root of x being cubed, cube root of y being cubed. Okay, and for that to happen, I need to have. So you will see that I need to have a plus here. And the factoring for this is, cube root of x plus cube root of y times cube root of x squared plus cube root of x, cube root of y plus cube root of y squared. Remember the sum of cube factoring? Okay, so some thinking process happened here, right? Okay, now the thing is, the things we have here is this guy. I'm missing this part to make it like that, right? So let's multiply the top and the bottom by that expression, cube root of x squared plus cube root of xy plus cube root of y squared at the bottom and on the top. So the purpose is such that then we get on the top, on the top we will get cube root of x squared plus cube root of x times cube root of y, which is basically cube root of x times y, and cube root of y squared. While at the bottom, as we expected, it becomes sum of cubes. So finally, after doing some cosmetic simplifying work, then I get x to the cube root of x squared plus cube root of xy plus cube root of y squared over x plus 1. Okay, now some combo work. The following seems to be hard, but it's more about being tedious. Some combo work. This is a good exercise on keeping yourself organized. Why? Because it's too complicated. If you are not organized, you can easily be lost in between. Number 78. The question is simplified. I prefer to say factor. And of course, simplify in between. Number 78, we have 6x minus 5 cubed times 2 times x squared plus 4 times 2x plus x squared plus 4 squared times 3 times 6x minus 5 squared times 6. To simplify this, we will factor. I hope you follow me in writing, because this will be quite tedious. The good thing is they already factored them partially for us. So we can easily see that we have common base 6x minus 5, right? Now for 6x minus 5, when we do factoring, we factor the smallest exponent, of course, right? The smallest exponent is square. So I will factor 6x minus 5 squared out. Then in the first term, I have 1 6x minus 5 left. And of course, the second term doesn't have any 6x minus 5 left. Okay. Then another factor that we can see easily is this guy, x squared plus 4. We have x squared plus 4 to the power of 1, x squared plus 4 to the power of 2. We choose the smaller exponent, of course, to factor out. That would be x squared plus 4, factor out. So you will not see any x squared plus 4 anymore from the first term, because that's all it has. You will see 1 x squared plus 4 left in the second. Next, I actually can factor 2 out from here and here. right? I can factor 2 out. So let me factor that 2 out. So if I take 2 out from the green ones, I have nothing left in the first term but 3 in the second term. Now the leftover 2x and 3 has nothing in common. Just leave them there. So this is 2x. This is another 3. So you really need to focus on. Then in the outside, we will get 2 times x squared plus 4 times 6x minus 5 squared. Or you can write it in different order, of course. Right? While the one inside the bracket now becomes 12x squared minus 10x plus 9x squared plus 36. Which combines to be the one inside the last parenthesis becomes 12x squared minus 10x plus 36. No, not 12. Should be 21. It should be 21. And you can try to factor it, right? The last parenthesis. You should try to factor it. But to know that it is factorable or not, you check the discriminant, right? B squared, which is 100, minus 4ab. This is a lot larger than 100. So this must be negative, which means it's not a square number. It means the last factor is not factorable. That's where we end. Now, why do we need to learn this? Because in calculus later on, you deal with this kind of thing in even worse shape. For example, this is not as bad yet, number 84. Number 84, we have simplify x squared minus 1 to the 4 times 2x minus x squared times 4 times x squared minus 1 cubed times 2x. Over x squared minus 1 to the 8. Now, to do this better, what you will do is you factor the numerator first and simplify, of course. So on the top, for example, you see x squared minus 1 as common factor, one of them to power 4, the other one to power 3. We, of course, choose the smaller one, right? So I will get x squared minus 1 cubed, such that my first term has extra x squared minus 1. The second term has no more. Oh, you know what? We also have 2x as our common factor, huh? So let me take that 2x out also. I write it at the front instead. Okay. It takes out from both of them, huh? And then nothing else, huh? Nothing else. So inside I have extra 4x squared here. Then simplify inside the bracket. Let me just add them right away. I think that's quite easy to see. That's 5x squared minus 1 over x squared minus 1 to the power of 8. Then you see we have common factor to cancel. I'm sorry, I make a mistake here. This should be minus. This should be minus. This should be minus. So this should be, this is wrong. This is wrong. This should be negative 3x squared minus 1. Let me just erase that. That's the good thing about having eraser here. I missed the sign here. It should be negative 3x squared plus 1. And then we cancel 3 of the x squared minus 1. And let me factor the negative out. So negative 2x times 3x squared plus 1 over x squared minus 1 to the power of 5. Right? Yeah, 3 of the base cancels. You have 5 left at the bottom. Now keep in mind that we will always factor out the smaller exponent, right? If we look back here, x squared minus 1, how many should we factor out? And you look at the exponent, oh, we factor out the smaller one, right? So we factor out x cubed, x squared minus 1 being cubed. Notice that this guy here multiplied by these give me the power of 4. Okay? Now, the reason I went over that because imagine if we need to deal with fractional exponent. Let's say number 88. I will write down the question and you try to work on that. Number 88. We have 1 minus x squared to the power of 1/2 and times 2x minus x squared times 1/2 times 1 minus x squared to the power of negative 1/2 times negative 2x big over 1 minus x squared to the power of 1/2 squared. Wow, that one is kind of hard to simplify. But I think I can show you that the denominator is actually simplifies quite nicely because the 1/2 to the power of 2 cancels there. So we for sure have 1 minus x squared only at the bottom. Now what I need you to do is take care of the numerator. Okay, take care of the numerator. Now notice that this has the same base with this. Now, because they are the same base, I will choose the smaller exponent, which is 1 minus x squared to the power of negative 1/2. So I have 1 minus x squared to the power of 1 here, minus nothing. Okay, notice that this guy plus this guy give me 1/2. Right? And then I can proceed with 2x. I have common factor 2x. Okay. This guy here, if I factor 2x, I get x are -1. What's left inside? I have x squared times 1/2. Let's make it nicer now. This is 2x times 1 minus x squared plus 1/2 x squared over 1 minus x squared to the power of 1/2. That's the one I get from above. This guy, positive on the numerator, becomes negative on the denominator. Times 1 minus x squared. Okay, so I get 2x times 1 minus 1/2 x squared if I combine like terms inside. Right, and at the bottom it becomes 1 over 1 minus x squared to the power of 3/2. And let me distribute the top. So I get 2x minus x cubed. I distribute the 2 but not the x. Distribute the 2, this is 2, distribute the 2, I get x squared over 1 minus x squared to the power of 3/2. It's nasty. You need to know how to keep track of your work here. Okay, now that's the end of 1.3. Your suggested homework here will be from number 49. 1.3 from number 49 to number 87. Good thing. Now let's take 10 minutes break. Right now. Okay. Yeah, the equal sign should line up and do not do pancake. I'm sorry, I didn't record it earlier. Let me write a note here. Don't do pancake. Don't pancake. For example, that 5x minus 4 equals to 2x minus 4. Do not do this. Don't do this. Here you will get the right answer. Though. Here you will get the right answer. But this method here, this pancaking method, does not work well, especially if you have fractions or decimals. Okay, so I don't recommend you at all to show the work this way. And believe it or not, there's no textbook, no Precalculus textbook show you any work like this. Okay, I can even say no intermediate algebra, no algebra 2, no algebra 1, no beginning algebra textbook show you work this way. Your teacher may show it this way because it is visually entertaining. Okay, it is visually entertaining. But easy method only works for easy questions. Okay, a good method will be able to tackle most of the problems. Okay, second, try to follow order operations. In other words, if you can simplify each side, then do that first. Okay, so suppose I have this example here, I distribute first and combine like terms. This will be 5x minus 8, right? And then I subtract by 3x the other side. and then I add 8. Thomas, if I do pancake, will you mark me wrong? Not really, but what I saw is students who stick with that method, they actually cannot go far in my class because their brain is so entertained with easy questions only and happy with easy answers. But once it gets more to more complicated work, they get stuck. Okay, now this is what I meant by follow the order operations. Instead of doing the following, don't do this. Don't. Some people, in fact, I saw some teachers actually doing this. Oh, you know what? I will put all the x's on one side and all the constant on the other side. And just combine, compute them all at once. Trust me, I don't think that's a good idea. Yeah, I don't think that's a good idea. So x equals to 23 over 2. See, Thomas, I get the same answer though. Yeah, do you want to wait until you get a wrong answer? Well, after all, here I did it first, so you know what's the right answer. In your test, you don't know what's the right answer. So you really depends on your method to solve the problem. And once you get larger number here, you may make mistakes. And what usually happened was actually, I saw people forget to change the sign. So forget to change the operation sign. You know, that's what I saw usually. Okay, so I don't recommend you to do it that way. So what happened if I do it that way, Thomas? I will still accept it, but if you make a mistake there, then I will penalize you from where you start deviating that leads you to a wrong answer, right? Sometimes you make miscomputation, not because of that miscomputation itself, but you set yourself up in a situation that you cannot compute it well. Okay, just like this. I give you some illustration. I have a student who actually come to me on a test on Monday test, and he said that he had a very bad headache and dizzy. And throw out. Of course, if when somebody's sick, Thomas, can I do makeup test? I give you a makeup test. Okay, I give you only one makeup test for the whole semester though, or the whole summer here. Now, it happens to be a regular semester class. So the thing is, like, the next time he had the same problem. The next test he had the same problem, headache, dizzy, and thrown out. Of course, I agree, nobody wants to get sick. But when I ask further, what makes you like this? Because it's not right for you to get sick on 2 of my tests, while so far we only have 2 tests. And then after some talk, it reveals that on Sunday, basically Saturday evening, going to Sunday, he went to party and get super drunk. And he has that hangover until he could not study on Sunday. Now you tell me then, is this person normal or not? Nobody wants to get sick, I agree, nobody wants to get sick. But this person purposely set himself up to get sick on Monday. But Thomas, nobody wants to get sick. I agree, but you know when you get drunk, if you drink too much, then you will have hangover. Of course, then you won't be able to study on Sunday and you won't be prepared on Monday. Right? Okay. So basically you cannot say that this just happened by accident. No, you did make yourself into that situation. Okay, now coming back to our illustration there. You may not make mistake at the beginning, but your method may lead you to miscomputation. Why? Actually, what's wrong here is this. What happened in this method is you need to compute all three numbers at once, while in this here, you compute only two numbers at once. Yeah, I have more steps, but every step is light. Every step is easy. Instead of like doing three numbers at once, I do two numbers twice. Okay. No wonder you tend to make mistake here, because again, you set yourself up into that complicated situation. Okay. Another illustration. Suppose you say, Thomas, I didn't do well in your test. Don't do well in your test. And that's because your test is too hard. I told you this class will be hard. So telling me that my test is too hard is like saying nothing new. We know it will be hard. Okay. So when I say, why is it so hard? Then later on that person revealed to me, didn't have time to study. What do you want me to say if you tell me you don't have time to study? Should I tell you that you should have time to study? I don't even need to say that, right? You know you need to have time to study. Okay, but revealing further into, oh, you know what? I don't have time to study because I need to go to my yoga class. You need it, but I guess you don't go to yoga every day if you don't study for your class, right? Okay, it's not like Thomas, I need to eat 24 hours a day. Then yeah, you don't need to do anything but eating, right? But yoga is not. I believe yoga is not a class that you need to go for 3 hours every day, while at the same time you don't have time to study at all for my class. No, balance your life. Okay, balance your life. I'm not saying yoga is wrong. Something wrong with you in your time management. Okay, now of course, this little thing that you don't take care at the beginning with routine, with discipline, will eventually leads to not doing well in your tests, and eventually not doing well in my class, and eventually you need to repeat the class. Eventually you need to postpone your transfer, you need to postpone your graduation, and you will get the job later, and in between you pile up education debt, student loan, for example. No. Too much risk. So little things that you're supposed to do, you didn't do it, you procrastinate, eventually it leads to a harder time. Okay? So no. Don't let this happen. Don't let this happen. So coming back here, don't set yourself up for making mistakes. Okay? And don't set yourself up for making mistakes. Now, I will leave you with that two rules first. I will go on again later on with the third rule. There are actually three rules. But that's the first two first. Let's do some problem from our textbook. In this textbook, we will actually focus on the first linear equation. That's the easy part. Second, rational equation. Rational equations, and then quadratic equation, in which we will solve using factoring, completing the square, and by formula. And then on top of that, we will also learn absolute value equation. And finally, radical equation. Now we have done a simple linear equation above. Let's do more. For example, question number 4. You will see, for example, when we do rational equation, eventually we may end up dealing with linear equation or quadratic equation. Maybe. Okay? Maybe. Let's see question number 4. We have x plus 5 squared plus 3 equals to x minus 2 squared. Don't forget the equal sign should line up. Okay, at least try your best to line them up. Okay, now then in the next step, what I will do, I will distribute this, I will FOIL that, and I will FOIL this. The next step should be done in the next slide. The next step should be done in the next slide. So the next step, x squared plus 10x plus 25 plus 3 equals to x squared minus 4x plus 4. Now we did this FOIL yesterday and I told you to memorize that, right? Now then what I will do, I will combine like terms for each side first, at least the left hand side here I can combine. Now, then you see that the x squared cancel, right? Now once you cancel the x squared, all of a sudden, now we are dealing with linear equation. So I will move the negative 4x to the left, becomes plus 4x. And subtracting by 28 both sides, I will get negative 4x, positive 4. Positive 4 minus 28. So 14x equals to negative 24. Next, I will divide by 14, right? Now, do not do pancake. Remember, I say do not do pancake. Don't write it this way. Don't write it this way. Your next step, which is dividing by 14, should be done in the next line. Okay? Should be done in the next line. So if you really want to divide by 14, show it next step. Okay, in the next step, you show 14x over 14 equals to negative 24 over 14. If you really want to show that division both sides. Now, the way I taught my pre-algebra student is we always undo the operation. The operation here is multiplication, so I will undo that on the other side. So x equals to negative 24 over 14. So undo multiplication becomes division on the other side. Now then I reduce negative 12 over 7. So this number 4 here, I hope summarize those 3 principles very, very well. First, equal sign should line up. Second, combine like terms on each side whenever possible. And third, the next step should be done in the next line. Principle number 3, next step should be done in the next line. Okay, not on the same line. That's for number 4. Now, what happens if we have a rational equation? Let's say number 6. Number 6, we have 7x plus 2 over 14x minus 3 equals to x minus 8 over 2x plus 3. In pre-algebra, I believe your instructor told you that you do cross multiply. When you have a ratio, a proportion, you do cross multiply. But the background of that cross multiplication is actually multiplying both sides by the LCD. If you multiply both sides by the LCD, you will see on the left-hand side, 14x minus 3 cancels. We have 7x plus 2 times 2x plus 3. While on the right-hand side, when you multiply by the LCD, 2x plus 3 will cancel, and we are left with x minus 8 times 14x minus 3. Okay, now you can get rid of the red writing, and you will see it's basically cross multiplication. Okay, but I teach you this anyway because there's a chance that sometime in the future you have a rational equation in which you cannot cross multiply. But you still can multiply by the LCD. That's why I teach you this method. Okay, now I go on. I will FOIL this. This is 14x squared. 21 plus 4. I say 21 from here. This is 21x plus 4x. That's 25x plus 6 equals to 14x squared. Oh, later on 14x squared will cancel, huh? And then negative 3 minus 112. That's negative 115x plus 24. So 14x squared cancels. Suddenly it becomes a linear equation. So 25x plus 115x equals to, oops, I go over line. Equal signs here. So 25x plus 115x equals to 24 minus 6. This is 140x equals to 20, oh no, 18. So I get x equals to 18 over 140. Of course, if I can reduce, I should reduce. That's 9 over 70. Now, when you solve an equation, note, when we solve an equation, when we solve for an equation and we solve in first, if it results in an identity, then the solution is all real numbers in the domain of the equation. However, if we result in a contradiction, then there is no solution. Let's say, for example, we do number 8. 2 over 2x plus 5 plus 3 over 2x minus 5 is equal to 10x plus 5 over 4x squared minus 25. We know that this guy is 2x plus 5, 2x minus 5. So what I will do is I will multiply by the LCD, which is 2x plus 5, 2x minus 5. Notice that you cannot do cross multiply here. If you want to do cross multiply, you need to combine this into one term first. Okay, that would be too long though. Okay, what I will do is I multiply by the LCD first. So this LCD method that we learned in complex fraction is actually quite useful, even for solving equations. Okay, now then on the left hand side, I will get 2 times 2x minus 5 plus 3 times 2x plus 5 equals to 10x plus 5. Distribute 4x minus 10 plus 6x plus 15 equals to 10x plus 5. I get 10x plus 5 equals to 10x plus 5. Now, that's an identity, right? Because if I subtract both sides by 10x and subtract both sides by 5, I end up with 0 equals to 0. Okay, so that's an identity, which means any number x, any value for x that you plug in will work as long as it is in the domain of the equation. Okay, now, so what are the numbers not in the equation? The numbers that make this 0. Or to be more precise, you can just look at this and see what makes it 0. That's the number you need to avoid. Okay, so we need to avoid 2x plus 5 cannot be 0. 2x minus 5 also cannot be 0. Because if it is 0, it will be undefined. Okay, so the solution will be all real numbers except 5 halves and negative 5 halves. Remember I said earlier, if you get an identity, then the solution is all real numbers except all real numbers in the domain of the equation. You need to kick out those that is not in the equation. Okay, that's the one I kick out. Now, this notation here, backslash, means except. Because what it does is actually doing what we call cut out. So you can read that as all real number, you cut out 5 half and negative 5 half. So Thomas, what does it mean to say contradiction? Contradiction. Let's say, for example, you end up with negative 4 equals to 3, which is contradiction. Okay, now when you see contradiction, you first say it's contradiction, which means there's no such x to satisfy. You will say either no solution, or you say the solution is empty set. The solution is empty set. Okay, now please be aware this notation is empty set. Not 0. Okay, 0 looks like this. That's 0. Okay, empty set is this. Okay, keep that in mind. Now, let's do more problems. Let's say I go ahead with number 14. Number 14, we have 3x over x minus 2 plus 1 over x plus 2 equals to negative 4 over x squared minus 4. Notice that x squared minus 4 factors into x plus 2, x minus 2. So let me ask you to have a hands-on experience here, multiply by the LCD. Multiply by the LCD, x plus 2, x minus 2. Okay, let me give you maybe 2 minutes for that, 2 or 3 minutes for that. Okay, okay, let's see, we will have 3x times x plus 2 plus x minus 2 equals to negative 4. This will be 3x squared plus 6x plus x minus 2 plus 4. We set one side equals to 0 because we want to do factoring. And for us to solve an equation, a quadratic equation by factoring, we need to set one side equals 0. This is 3x x plus and plus 2 and 1 like this. The product of two factors equals to 0 if any one factor equals to 0. So x equals to negative 1/3 and x equals to negative 2. Oh, however, be careful. Notice that we need to reject this one. Okay, because we know that x plus 2 cannot be 0. Right? Okay. So our final answer will be, what you can do is just cross that out and then box this one is good enough. Okay, so from here, we see one example on how to solve the problem, a problem by factoring. Okay, so you see that we start from rational equations, multiply by LCD, suddenly becomes a quadratic equation, and then we solve that by factoring. Now, there are times, however, it's not solvable by factoring. And for example, if we see question number 18, x plus 5 squared equals to 29, right? Now you see that the right-hand side here already, the left-hand side already a perfect square, and the right-hand side is positive. It cannot be negative. If it is negative, then it is not a real number. Let me say this. We know from yesterday that x squared will be at least 0. So if I have x squared equals to, let's say, negative 4, then there is no real number whose square is negative in general. It's a complex number. Okay, so if you have this x squared, whatever something square equals to a negative number, you will say no real solution. Now, if it is positive, however, what do? We apply square root to both sides. But remember, once you apply square root, you need to use that plus minus sign right away, right away, right away. Now, please don't write it this way. Please don't write it this way. X plus 5 squared equals to 29. And then you say, oh, what I will do next is I apply square root. So you write the square root here, you write the square root here. No, 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 no. No, don't write it that way. Why? Because the next step should be done in the next line, right? Okay, the next step should be done in the next line. And when you do it in the next line, you're supposed to put plus minus at the same time. Okay, don't wait, don't wait. This is two things at once, because the rule is actually that x squared equals to c implies x equals to plus minus square root of c. Okay, that's the rule. The rule does not say this. The rule does not say x squared equals to c, x equals to square root of c, x equals to plus minus square root of c. No, that's not what the rule says. That's not what the rule says. The rule say when you apply square root both sides, you apply plus minus at the same time. Okay, now in this number 18, the left-hand side already a perfect square, so I can apply square root property and then move the positive 5 to the other side becomes negative 5. Now, if you have branching solution like this, I'd like you to rewrite them, split them up. Negative 5 plus square root of 29, negative 5 minus square root of 29. Okay, now that's square root property if one side already have a perfect square. Now what happens if we want to use completing the square method? Now we use completing the square method. We use completing the square method on a trinomial when the leading coefficient is 1 and the coefficient of x, the coefficient of the variable, is even. Then completing the square method is better. Completing the square method can actually be used in every case of trinomial equation. Every time. If you have a trinomial quadratic equation, to be more precise. Every time. Okay, we can always use completing the square method to solve a quadratic equation, always. However, it will be the most efficient if the leading coefficient is 1, coefficient of the variable is even, and of course, and not factorable. Okay, the way we complete the square mimics the way we complete the square when we did the equation of the circle. Basically, I will move the constant to the other side first. So you see the leading coefficient is 1 and coefficient of x is even, right? Okay, now if that's the case, then I move the constant to the other side. Okay, so only variables on the left. And then I ask myself what number I need to add. Negative 4 divided by 2, whatever the coefficient b, the coefficient of x, which is b, divided by 2, whatever the quotient, squared. I hope you remember this procedure from day 1 on Monday. So I will add 4 to both sides to complete the square. Then on the left-hand side, I get x minus 2 squared equals to 6. Now from here, then, we apply square root property. Okay, x minus 2 equals to plus minus square root of 6. X equals to 2 plus minus square root of 6. Don't forget to split it. So x1 is 2 plus square root of 6. X2 equals to 2 minus square root of 6. Okay, warning. If a quadratic equation is solvable by factoring, then solving by completing the square by other method or quadratic formula will get 1-point penalty if you get everything right. If you get everything right, you get 1-point penalty. Okay, why? Because factoring is faster. Okay, you always need to check if it is factorable. And we know that it is factorable if the discriminant is a square number. Keep that in mind. Okay, now I will give myself a break. Of course, you too. We will come back at 1:15. And at that time, we will do a quadratic formula and solving absolute value equation and solving radical equation. Again, what happens if we cannot solve it using completing the square method and it's not factorable? Then we solve it by formula. Okay, let's say, for example, you know what? I don't like problems from the book. Let me use my own problem. For example, solve 2x squared minus 3x minus 4 equals 0. Let's say we have that quadratic equation, and I believe it's not factorable. And the leading coefficient is not 1. Even if I divide by 2, well, if you want, this is just trying, okay? If I divide by 2, I will get 3/2 here. So even if I make the leading coefficient becomes 1, the coefficient of x is not even. So I don't think I will go to completing the square method here. Even if it is still, it's doable. It will be doable. But I don't think I will do it that way. Okay. What I will do then is I will apply quadratic formula. Quadratic formula, just to remind us, if we have ax squared plus bx plus c equals to 0, then x1, 2 will be given by a long line for fraction negative b plus minus square root of the discriminant b squared minus 4ac over 2a. Okay. Now, I strongly suggest you to compute the discriminant first. Okay, I suggest you to compute the discriminant first if you use quadratic formula. Like in this case here, my A is 2, my B is -3, my C is -4. So my discriminant will be B squared minus 4AC. That's 9 plus 32, that's 41. Now, why do I ask you to do the discriminant first? Well, because if the discriminant is negative, then there's no real solution. If the discriminant is negative, then there's no real solution. If the discriminant is a square number, then you know it's actually factorable. Okay? If the discriminant is positive but not a square number, then you go on. Okay, let's put a note there. If the discriminant is negative, then the solution are not real numbers. It doesn't have real solution. If the discriminant is a square number, then you need to stop, then try to factor instead. Okay, try to factor instead. Only when the discriminant is positive and not a square number that you go on. So 41 is not a square number, so I go on, then my x12 will be negative b plus minus square root of the discriminant over 2 times 2. That's 3 plus minus square root of 41 over 4. Now don't forget, we have two solutions there, therefore I would like you to split them up and of course simplify whenever possible. 3 plus square root of 41 over 4, 3 minus square root of 41 over 4. Now, what about absolute value equation? I give you the basic first, and tomorrow I give you the more advanced one. The basic ones is the following. The basic one is the following. If we have absolute of x equals to a positive number, or C a positive number, then either x equals to C or x equals negative C. Yeah, so a little example. Let's say for a little example, if I have absolute of x equals to 3, so either x equals to 3 or x equals to negative 3. Visually, what are x's that has, what are the values, what are the x's that has distance 3 units from 0? 3 units from 0 are 3, which is 3 units to the right, or negative 3, which is 3 units to the left. Okay. Now what happens if x equals to 0? For absolute of x equals to 0. Well, the only time absolute of x equals to 0 is when x equals to 0. Okay. Now notice that absolute value actually represents distance. Okay, and therefore distance will be distance from 0 in this case will be either a positive number or 0, but distance cannot be negative. Okay, in other words, if you have absolute value something equals to a negative number, just say no solution right away. Okay, for example, when we have absolute of x equals to -7, back right away, no solution. I think that's the easiest question, right? Yeah, absolute of anything should be the distance, absolute value should be positive or 0. Now, the thing is, what happens if I do such a variation? If I have 2 absolute 5x plus 2 minus 1 equals to 5. From the rules I show you here, we basically need to isolate the absolute value by itself first. Okay, I want to isolate that first. So I will add 1 and then divide by 2. So isolate the absolute value first by itself. Okay, now then once you have absolute blah equals to 3, once you have absolute blah equals to 3, then either blah equals to 3 or blah equals to -3. Okay, so isolate your absolute value first. Okay, now then from there we go on. This is 5x equals to 1, x equals to 1/5. That's my x1. 5x equals to -5, x equals to -4. That's 2. So I have 2 solutions for this question. Okay. Now tomorrow, so to prepare you for tomorrow, I will teach you how to solve questions that has variable on the other side. Let's say absolute of x plus 5 equals to 2x minus 3. That's what we will do tomorrow. Okay, more things to say in that case though. More things to say in that case. Okay, that's for absolute value. I'm about to go into radical equation. Radical equation. To undo a square root, to cancel a square root, to undo a square root, in an equation, we square both sides of the equation. Once you arrive at this level, you must have seen this procedure. Okay, but keep in mind, that this step may give us extraneous solution. Which maybe then so we need to perform checking on each solution we obtain. Okay, now I give you an exception. We don't need to check. You can always check your solution if we square from the following situation: square root of something equals to a positive number. If you square from something positive, you don't need to check that. Okay? If you square from something positive, you don't need to check that. Now, for example, you still can if you want to check, fine. Suppose, for example, we have square root of 2x plus 7 equals to 4. Notice that the right-hand side already positive, right? Okay, so if I square both sides, to cancel the square root, right? When you square both sides, the left-hand side, the square will cancel the square root. The right-hand side, I get positive 16. So 2x equals to 9, x equals to 9 over 2. Okay, now, because the 4 is already positive, you don't need to check. Even though if you check, you will still get it confirmed to be the right answer. Okay, now, this also means that if the other side is negative, you don't need to check, you don't need to go further. Suppose square root of 3x plus 9 equals to negative 2. The square root will always give you 0 or positive. Remember the principal branch that we talked about? Right? Square root will always be square root of something. Square root of something will always be at least 0, cannot be negative. It behaves very similar to absolute value. So if you have square root something equals to negative number, just go ahead, say no solution. You don't need to go far. You can solve it though. No solution. Okay, but suppose you don't realize that and then you square both sides, go ahead, you square both sides. But notice the right-hand side is not a positive number, right? So it doesn't fall into this category here. It doesn't fall into that category. Because the other side is not a positive number. When you square both sides, you need to check. 3x plus 9 equals to 4. 3x equals to negative 5. X equals to negative 5 thirds. When you check, square root of 3 times negative 5 thirds plus 9, is it equals to negative 2? Now, that's how you show your checking. You put a question mark equal on the top of the equal sign. So I get square root of negative 5 plus 9, is it equals to negative 2? Square root of 4, is it equals to negative 2? No, it's not. So, no solution. Now, notice that if you don't check that, you don't realize the solution -5/3 is actually an extraneous solution. Okay. The thing is, what happens if we don't know if the other side is positive or negative? That is when the other side has variable. Example 3. Suppose I use question from number 34. We have square root of 3 minus x minus x equals to 3. So I will isolate my radical first, just like absolute value. Isolate the absolute value first. Okay, in radical equation, you also isolate the radical. So square root of 3 minus x equals to x plus 3. So now we don't know if the right-hand side is positive or negative. It depends on the x, right? It depends on the x. If x is less than -3, then it won't be right. Okay, if x is less than -3, then it won't be right. But we don't know. We don't know. We don't know. What I can do is just proceed as usual. I will square both sides. So on the right-hand side, I get x plus 3 being squared. The left-hand side, the square will cancel the square root. The right-hand side, I need to FOIL it. And then set one side equals 0. I get x squared plus 7x plus 6. So x plus 6, x plus 1. So either x equals to -6 or x equals to -1, right? Now then we need to check. Now it is possible that both solutions wrong. It is possible that both solutions right. We never know. Check when x equals to -6. What happens? Square root of 3 minus -6. Is it equals to -6 plus 3? That's square root of 9. Is it equals to -3? 3 is not equals to negative. So -6 is not a solution. Okay, now then let's check x equals to -1. Square root of 3 minus -1, is it equal to, I'm sorry, I'm supposed to check against the original question. My bad. I need to check against the original question. My view earlier was abstract. So I'm supposed to check against that one. My bad. I need to cancel all of this. I need to check against the original question. So it will be minus -6. Is it equals to 3? Square root of 9 plus 6. Is it equals to 3? 3 plus 6. Is it equals to 3? The answer is no. And then when I check against the other solution, against the other solution against the original equation, is it equals to 3? That's square root of 4 plus 1. Is it equals to 3? 2 plus 1, that's equals to 3. Okay? 3, that's a check. Then you summarize, so x equals to -1. Okay, so isolate the radical first, isolate the square root, and then square both sides. Because somewhere in between of the process you square both sides of the equation, you need to check whatever answer you have. Now you do next one. Number 36. Number 36, x plus square root of 5x plus 19 equals to -1. I want you to solve it. Let me give you 1, 3, 4, maybe 4 or 5 minutes from now. Okay, let me ask you to try it. Okay, let's work it out. I will move the x to the other side first, so it becomes -1 minus x. So we don't know if the right-hand side is positive or negative. It seems like it is negative though, but please be aware that if your x is negative, let's say your x is -6, right? It becomes positive, right? It becomes -1 plus 6, which is +5. In other words, simply because it used negative sign with the variable, it doesn't mean that's negative number. No, you have variable here. If the variable is negative numbers, then -x becomes positive. Okay, so no, we don't know if that's positive or negative yet. What we can do, we square both sides. When we square both sides, this is what we get. That will be x squared plus 2x plus 1. Then, because it's quadratic, I set one side to be 0, x squared minus 3x minus 18. Now I get x minus 6, x plus 3. So either x equals to 6, let's call that x1, and x2 is -3. Now check. Check against the original equation. So 6 plus square root of 5 times 6 plus 19, is it equals to -1? Six plus 7, no, it's not -1. Okay, so 6 is not a solution. Let me check the second one, -3, the second solution. So -3 plus square root of 5 times -3 plus 19. Is it equals to -1? Square root of 4, huh? So -3 plus 2 equals to, is it equals to -1? Yes, that's right. Then you summarize, so x equals to -3. Okay? Now remember that it is possible that both of them are solutions. It is possible that both of them are not solution, therefore it has no solution. We never know. Okay, you need to check each one of them. Okay, simply because the first one not a solution doesn't mean the second one will be the solution. No, you have to check both of them. Okay. Now we are actually almost pretty much done with the material. Now let me go to the combo one. Yeah, tomorrow I still need to come back and deal with the absolute value equation style when you have variable on the other side. But the following is, actually, let me just name it more properly. The slightly more advanced method, the situation, something called Solving quadratic-like equation. Solving quadratic-like equation. Let's say, for example, I try to get you an easy one first. Suppose if I have x to the 6 minus 9x plus 8, 9x cubed plus 8 equals 0. Now notice that this guy here is the square of this guy. As if we say the following: if we let u equals to x cubed, then x to the 6 will be u squared, right? Okay, so I do that little substitution such that I get u squared minus 9u plus 8 equals to 0. Now, then the plan is I will solve for you. The plan is I will solve for you. U equals to 1, u equals to 8, and then you substitute that back. And then solve it further. That's the plan. Okay. Now we say it's quadratic-like because the equation has 3 terms, and one of the term is the square of the other one, and the last term is a constant. The other term here is a constant. Oops. This part here is a constant. So basically, using some little substitution, you can rewrite it into a quadratic equation. So you substitute x cubed in this case by a u, and suddenly it becomes a quadratic equation. Now, let's say, for example, I do number 42. I have 2y to the 1/3 minus 3y to the 1/6 plus 1 equals to 0. Notice that this guy here, y to the 1/3, is actually the square of y to the 1/6. Okay. So let u equals to y to the 1/6. Then when you square that y to the 1/6, you get y to the 2/6, which is y to the 1/3. Right? Do you see that? So the equation now becomes 2u squared minus 3u plus 1 equals 0. Okay, and then I believe you can factor it. Fast forward, you will get u equals to 1/2 and u equals to 1. Okay, you solve it yourself. Okay, you solve it yourself. Factor it. Okay, and then I look back, I get, oh, my u is y to the 1/6. Okay, now remember, the power of 1/6 is the 6th root, right? The 6th root. So to cancel that 6th root, I take both sides to the power of 6. So I get y equals to 1/64. While here, blah, 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 I get y equals to 1. Okay, I have 5 minutes left. Let me do one more problem. Actually, you can do this, but I do it for you. Okay. Number 40, which actually has two different ways to do this problem. This question here has two different ways, two totally different ways to do this problem. Yeah. One way by quadratic like, so you say let u equals to x to the negative 1. So our u squared will be x to the negative 2, right? So we end up with u squared minus 2u minus 35 equals 0. And then when you solve that, you need to show that though. Okay, don't do dot dot dot. No, 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 no. I have the right when I teach that, but you don't have the right to do that in your test. Okay, yeah. And you will get u equals to 7, u equals to negative 5. And then I put it back, x to the negative 1 equals to 7. It means 1 over x is 7. I do the reciprocal, both sides, I get this. So likewise here, with the same similar procedure, I get x equals to negative 1, 2. Now that's the first method. What is the other method, Thomas? It happens that this is solvable using, if we can see that from rational equation. So this is 1 over x squared minus 2 over x minus 35 equals 0. Now then I multiply by the LCD x squared. Multiply by the LCD x squared, and I get 1 minus 2x minus 35 x squared equals 0. Then we move to the other side. Basically, or you can also say multiply both sides by a negative 1. And this is factorial by 7x, 5x, minus 1, plus 1. Yeah, you can try to factor. Okay, and then we get x equals to 1 over 7, x equals to negative 1/5. But I believe when you see how I show the work here in blue, we may get slowed down when we try to factor this thing here, because we get large number, right? Yeah, we get large number. The ones really help though. The one here really helps to shorten my time to factor it. But still, I think if I see this question, I will do it with method number 40. I mean, the first method instead. Okay, now your suggested homework from here, will be 1.4, pretty much all of them, all of them, number 1 to number 41. Okay, but I would like you to, after you're done with those, then focus on number 37. I think number 37 is actually, I should say that number 37 is that WTE. That's what the equation. The solution is so ugly that you don't expect that to be your solution. Okay, that's for today. Tomorrow I will finish up a very little part from this 1.4. and with that absolute value equation. And then I will go on to 1.6. I think I will spend some time on that 1.6 though. And then I will skip 1.5. Okay. If I believe I should have some chance, I just need another 5-10 minutes for 2.1. So tomorrow I should finish 2.1. And on Friday, I should be able to finish up to 2.4, I believe. Now, before I let you go, stop the recording.